So test preparation. We have the test geometry, first of all, we start with the physical setup, position the test structure, mount transducers, which would typically be accelerometers, connect transducers to the front end, connect sources to power amps and shakers if required. And then the software setup, which is obviously what we'll focus on, since at the moment we're talking about software. Import the test geometry, assign location and direction to transducers, channel coupling, whether that's AC or AC with power to transducers, sample rates, windowing, averaging, drive levels, and so on. Within Test for I-DEAS, the channel setup can be formed, which can often be one of the most time-consuming parts of the test, with either the channel table or the channel tables, which are two ways of looking at the same data. The channel table view, the form shown here, presents data for a single channel and allows channel coordinates to be graphically. See the data here, the coupling, the coordinate. Someone saying that the audio keeps going in and out. Someone's reporting that. But I'm getting noise from somebody. So I'm going to take the step of muting a few people. So we have the channel view here. As I say, that shows data for a single channel. You can click the pick button and then select the transducer location for that channel from the graphics region. Now you can scroll through the channels one at a time, or select the little question mark here and jump to any specific channel. In contrast, the channel table spreadsheet shows data for all of the channels simultaneously, and we will see that on the next slide. As a convenience, we provide a front-end simulator. The purpose of this, it obviously simulates your data acquisition setup, and the advantage of this, it allows you to generate a complete test setup with no hardware attached. This was considerably upgraded in version 6.3 and now supports an arbitrary number of
channels. Thank you. I can hear the audio now.
Sorry, what was that?
Yeah. Yeah. I don't know. Maybe my mic is wired. But okay. Either way.
Yeah, if you could mute your mic, because I'm getting interference from a few people. I've muted you here. So the front-end simulator can be used, say, do a sitting at your desk, then move the model tab, and then much of this slide looks at the channel table spreadsheet, and as I said, gives a global view of all of the ones. From this form, you can set the number of reference and response channels, look at the list of transducers, and manage the transducer assignment to channels, and a whole bunch of other features which I won't list. Some of the key things are the user controls which columns are displayed. So if you're using tachometers, you can add those columns to display. If you're not, then you can leave them hidden. The values can be cut and pasted between cells. Or you can, for example, if you need AC with ICP on all channels, you can set it on one, copy that, and paste it to all the remaining channels. They will all set up. And the data will be saved and recalled in any other setup. Going along with the channel setup is the transducer setup, which can be managed from the channel table spreadsheet or again from another dedicated form here. And this allows you to define a transducer, serial numbers, type, sensitivities, calibration date, and then simply assign them to the channel. This next slide, we've got a few of these scattered throughout the presentation, but these look at some of the enhancements that we're planning for the product. I should probably add a little legal disclaimer that these represent plans. They don't represent a commitment to do this, but these are plans that we have. And one of the things, though, that is very imminent is TED's support for the Sentinel EMX front end. This will allow you to load your transducer data into the channel table spreadsheet via TEDS, and we hope to announce that very shortly. So if you have TEDS transducers, this will considerably shorten setup time and also reduce potential setup errors. I mentioned that the channel table spreadsheet yeah, we're still getting a lot, sorry, but we're still getting a lot of audio interference from somewhere. Control of, one thing we plan to add is control of sources from the channel table spreadsheet. I mentioned that you can set up the input channels, but there are plans to allow the sources to be set up from there. And the form you see over on the right is the current incarnation of that. The project's in progress. So this is the form. Obviously big buttons to turn the sources on and off, but sliders to control the levels, master slider to bring up all the levels at the same time, and options, of course, to select the signal type and source ramps, frequency ranges, and all of the other options associated with the sources. There will be later enhancements of that to also include the global setup parameters for the test, frequencies, sample frequencies, windowing, averaging, and other parameters. So that's test setup. Moving along to data acquisition, and of course by that we mean capturing of time-varying signals from noise and vibration transducers. And I'm sure that things we're all familiar with. We excite the test object either with a shaker hammer or even operational loads, record the response, and which we currently analyze. Test for I-DEAS is currently supporting VTI's VXI and the new Sentinel EMX data acquisition front ends. Chris Gibson from VTI will be telling you more about the EMX front end very shortly. Data acquisition methods include continuous time histories, basically just log everything to disk, including supporting I-RIG timestamps. Input can also be frame-based with triggering and averaging, and on VXI systems we support the throughput disk. So the hardware has an internal hard disk and data is logged to that and then read back later into the software. There's a list here of the standard measurement data that you can acquire, and it's a long list. This is just for one of the measurement modes, but it's time histories, various spectra, coherence, and a long list. There's also a time capture option, and this is an option that whatever type of data acquisition you're doing, it streams all incoming time data to a hard disk, allowing the same test to be analyzed in multiple ways. So set up the test, produce the data that you want, but by sending all the time data to disk, you can always repeat that test using the identical data, or reanalyze the same data and produce different set of results types. Test I-DEAS has extensive data acquisition, preview, and monitoring options. Level display of up to 300 channels, which is shown here. Separate levels for positive and negative excursions. And you can view up to 300 channels with these level meters. And of course, scroll through the channels with the higher number. But there's also a function display for up to 20 channels, with up to 2 displays per channel. These are shown at the bottom right. Where here we're looking at time data, and just for showing each frame as it's acquired. And there were some major upgrades to this capability in 6.0, some significant speed ups of the display, and also some enhancements to the formatting and the user's ability to control what the displays look like. And these functions actually support, these displays support interactive zoom, cursors, copy and paste, and that all can be done during monitoring or during preview. In preview mode, of course, during preview, we're not actually storing any data, but we're showing the signal, and that can be used to set up levels. So we provide an auto range option and also an optimized option which scales the displays so that you can see all the data. And another option that was added was to log all overloads to a file. So if you're logging data to a file, if you're capturing a lot of data and it's not always, you want to know where the data overloads occurred, then they will be logged to a file, and you can go back and check where the overloads happened, channel, and when. A tool that we added for rapid review of acquired data is the XY browser. This was new in 6.0. Has extensive filtering to allow you to select the functions that you want to view. Use the usual shift and control click to select multiple functions, and you can copy and paste live documents in Microsoft Office or a bitmap to anywhere. So for example, with here where I have an active document, I can, for example, remove the cursors, change the x-axis to logarithm display, and so even in the Office document, you can choose how the display looks and make many changes and read values of it. Future enhancement for data acquisitions. One thing we're planning here is what we're calling a time history recorder, and this would be a standalone application. that certainly initially acts as a digital tape recorder. The user interface on a spreadsheet, and then once you've set up everything, the data, all the setup information and the time data will be sent to a single file using a existing time capture format. And it will support data display, so you can see real-time data for one or more channels. And then, of course, the data, once you've used this for recording the data, you'll be able to read it with tests for I-DEAS and post-process the data there. So that's data acquisition. At this point, we've looked at the test setup. We've looked at actually acquiring the data, and now we're going to take a look at some of the options for post-processing it. And one of the first types of post-processing is just taking the raw time data and manipulating that. Test for I-DEAS can efficiently edit and display time histories of any length. It's basically disk-based, so there are no memory limitations, as everything is handled essentially on a block-by-block basis using the disk. Sections can be removed, replaced, or modified. There's a good selection of filtering available, extensive range of single math operations, scaling, windowing, weighting, etc., and some multi-math operations which use data from multiple channels. And so you can add channels, subtract them, and do other operations that require more than one channel. And you can also generate statistics on frame-based statistics, which shows statistical values from the time histories. The next, and probably the most common post-processing application, would be modal test. And again, I suspect most of you are familiar with that. Essentially, the goal is to, for the structure under test, determine natural frequencies, damping ratios, mode shapes, modal masses, basically to characterize the dynamic performance of the structure in terms of a series of modes. So again, we excite the test structure with shaker or impact hammer, acquire the test data, and then do the modal extraction. Test for I-DEAS has a complete set of tools for estimating the modal model and has support for multiple testing methods. These include impact testing, either with a roving hammer or roving accelerometers, where you just excite at the same point. Single shaker testing, multiple shaker testing, and for shakers you can use a signed step or random shaker excitation. The goal here, of course, is to generate the frequency response function between the excitation points and all of the measured response points. Once you have, with the FRFs, software will calculate a number of mode indicator functions, multivariate MIF, the normal MIF, and power spectrum. And those will show you where you have modes. And then it also offers a wide range of curve-fitting algorithms, a couple of local methods, which are suitable for widely spaced modes where they are well separated in the frequency domain, single degree of freedom polynomial and circle fit. We have some single reference global methods, so they use the data, the full FRF, but only for a single reference, a direct parameter frequency domain and complex exponential. And finally, and probably the most commonly used, the polyreference global methods. These include a time domain polyreference, a frequency domain polyreference, orthogonal, and the AF poly or alias-free polyreference from ATA engineering. The polyreference frequency domain method and AF poly have been implemented as easy-to-use wizards that guide you through the mode extraction process. And this is the example of the polyreference frequency domain. It's called the Advanced Modal Wizard, and makes modal analysis a three-step process. You set up options, select references, select the frequency range, and view the mode indicator functions in step 1. Step 2, you're presented with the stability diagram as shown here. And as you hold the mouse over a given mode, it displays frequency, damping, and complexity. Anytime you select a mode, you immediately see an animation of that mode in this window in the top right of the display. You can filter modes, selected modes based on frequency and damping stability with user-settable criteria, and you get immediate feedback of the synthesized and measured frequency response functions in the window in the bottom right. So as you're picking modes, just click on it. It's added to the list of modes, which is included in the FRF synthesis. You click it again to clear it. So you can quickly build up your modes while ensuring that you get a good match on the frequency response function. And finally, step 3 is mode validation. We do final mode selection and then save it to files. And when you exit there, they are available in the post-processing tools to be viewed. Planned enhancements for modal testing would be additional curve fitters in the Advanced Modal Wizard. As I mentioned, we have separate wizards for Advanced Modal Wizard and AF Poly. We'd like to consolidate them into one and also bring in many of the other curve fitters into that. And that will offer the choice for the same algorithms of manually stepping through each stage of mode extraction or using the wizard to guide you through them. Part of modal analysis, of course, is post-processing. Once we have extracted the modes, we want to see them. And within Test for I-DEAS, we can calculate the MAC matrix for either a single set of test results, giving us an auto MAC, or for two separate sets of test results. And you can compare the modes from the two. And we see a MAC matrix display down on the bottom right here. This is an auto MAC, so our diagonal terms are all 1. And in this case, the off-diagonal terms are quite low, indicating that the test has enough test points to clearly distinguish between the modes of the structure. We have the shape browser, very similar in concept to the XY browser, that provides a tool for rapid viewing of mode shapes. Again, it provides animated wireframe, dynamic rotation, and again, you can cut and paste the display into Microsoft Office documents. So again, you get the functionality, the ability to make changes to the display even in PowerPoint presentations like this or in any other report. To view these dynamic pictures on a machine doesn't have test for I-DEAS installed, you simply need to download and install the free viewers. And then we have another post-processing tool, Visualizer, that provides dynamic pan, zoom, and rotation, shaded console plots with up to 50 color bands, side-by-side views with up to 4 viewports, and also criterion plots for highlighting parts of the model with deformations in a specified range, which can be based on %. So you can look at the regions that have top deflections, the highest deflections, and you apply other criteria to the display. Another application area is rotational machinery. And of course, the goal of that is to characterize the rotational vibration and noise, typically arising from out of balance conditions, however small, on rotating machinery. We use the tachometer to measure rotational speed, and the focus is on harmonics of rotational speed, also called orders. So rather than expressing things in the frequency domain, it's typically expressed in terms of orders or harmonics of the rotational speeds. Testing is done by operating the machinery over a range of speeds, acquiring the test data, and then identifying the orders from the tachometer input. Test for I-DEAS will accept tachometer input on a dedicated channel or on any of the analog channels using both a pulse input. You specify the number of pulses per revolution, or a DC proportional input. Then, of course, you specify the RPM per volt. Again, we have extensive visual monitoring of the data as it comes in. Shown here is a waterfall display of a time-varying process. You can see the changes as the rotational speed changes quite slowly here. And we can also use the geometry to pick points to select where we want to view the data. There's an order tracking option that synchronizes the data acquisition sample rate to the rotational speed, and then really the data acquisition at that point is working in terms of orders rather than equal time interval. The sample rate is samples per revolution rather than per unit time. One of the key tools for looking at results from rotational machinery is our interactive slice tool. And this two views have shown on this on the right. And at the center of it is a 3D display, which can either be a sonogram, as shown at the top, or a waterfall display. And then you can view slices through this. So on the left, by the y-axis, is a slice taken vertically through the display, parallel to the y-axis. Along the bottom is a slice taken parallel to the x-axis through the point where the cursor is placed. And then over on the top right is an order tracking filter that takes the section along a line through the display. So, and again, you can look fundamentally at sonogram or waterfall and pick. It shows the points where the slices are made in red, and look at orders or the other views of the data. Again, these can be directly printed or posted into Microsoft Office documents. Test for I-DEAS has the ability to perform acoustic measurements. We can perform acoustic intensity measurements. The form on the right here, this would be where you enter the information about the acoustic intensity probes, which of course are two-channel devices, so you identify a pair of channels, the spacing, and other information about that. Of course, sensitivity information will come from the channels themselves. Allows you to determine acoustic intensity over a test model, and amongst Test for I-DEAS' many calibration methods that it offers is the ability to calibrate for phase compensation on the acoustic intensity measurement microphones. Another feature in the area of acoustic is noise path analysis. This allows you to evaluate the transmission paths, structure-borne transmission paths of noise through a structure. It allows you to rank the importance of individual paths and basically to determine whether noise problems are caused by a structure that's sensitive to low forces, or whether it's by large excitations of a perhaps relatively insensitive structure. The form below is defining measurement points for one of the measurement methods. So this one is for the matrix method. You list where you make all the measurement points, which directions you're going to measure in, and then of course you make those measurements, and then use the software to do the analysis. And a typical output is shown here on the right, where we have the ranking of various paths, which are numbered here, 1, 2, 3, 4. We can see the noise paths through the structure, how significant they are at this particular frequency to the overall levels. So you can see that doing anything with noise path number 6 is probably not going to make any difference, and you should focus on 4 and 7. And the software offers a number of different solution methods, and these require different measurement strategies. But the goal here is to develop a complete and reliable database and understanding of noise transmission paths within a structure. And obviously that leads to improving the noise and vibration performance. Another part of processing, and an important part, is generating reports. And Test for I-DEAS provides a tool for that, the reporter module. It's a tool that allows you to quickly view geometry, functions, shapes, and time data by simply dragging and dropping it onto the reporter. And this data can be in either the native Test for I-DEAS format or in universal files. One of the key things is the reporting wizard, which allows you to rapidly generate reports. You basically start with the data loaded into a reporter that you want to generate the report for, and a Microsoft Word template. Use grouping options to determine the data to be plotted. Sorting determines the order of plotting, and then filtering determines the actual functions that you will plot. And this will then output a Microsoft Word document, or create a Microsoft Word document that has all of the charts and figures that you need in them. There's some optional modules to the reporter, including a shock response wizard easy processing of shock data, and also an operating deflected shape wizard. And the final application is actually something, a brand new product that we're about to release, and it's normal mode tuning. We've previously had a normal mode tuning product, but this is a blank canvas replacement. We literally started from nothing, with pretty close to no soft common code between the two applications. Normal mode tuning is used to excite a structure in a pure normal mode. You drive the structure with multiple shakers. You vary their relative amplitude and phase to obtain a pure mode, which you check by looking at the phase of the response channels. So obviously it can control the frequency, phase, and level of multiple source outputs, and can perform a signed sweep with an automatic sweep rate option based on structure settling time. You basically set the settling time of the structure in terms of number of cycles it will take to settle after a frequency step, and then the software will make the step, wait the settling time, gather one frame of data, present the results for that, move on to the next frequency. Or you can set the larger frequency step and control it based on time. Normal mode tuning supports VXI and the Sentinel hardware from VTI. It will control up to 20 sources, supports up to 2048 input channels. Channel ranges can be set automatically. See on the form here, you can specify a percentage overhead, then you click the auto range button. Master level control means you can keep the same force pattern but vary the amplitude very easily to look at structural nonlinearities, and the waveforms and mode shapes can be captured to be viewed and processed in test for I-DEAS. This slide shows the display channels. At the top we have a level display for all of the channels. If they're overloaded, they would appear in red rather than green. The next display is input channel, the actual raw signal. Not surprisingly, it's sine waves. And then we have Lissajous figures and the amplitude sum versus frequency for specified channel range. Since I only picked one channel, it's basically plotting the FRF for that single measurement point. And then we have the complex plane scatter plot shown partly covered here, and this allows you to accurately see the phases between the various channels. So that's the end of the descriptive part of the presentation for the software, and I just wanted to bring together into one slide all of the enhancements that I've discussed. And again, these represent our current plans, not a firm commitment. Not mentioned before, but is the imminent announcement of support for Windows 8.1. We're just concluding our testing of the software on Windows 8.1, and at this point anticipate making a formal announcement in the very near future. And of course, we always welcome user input, suggestions for new features, enhancements, how we should be prioritizing our activities in terms of those features and enhancements, and of course prioritizing bug fixes. So user input is always welcome in those areas. And other things we're looking at is a sign tracking option. but that's still sort of in the distance rather than the near future, unless we start hearing some requests for that. So that's all I wanted to discuss on the software side, and I'm going to hand over to Chris Gibson to take care of discussing the hardware.
Chris, thank you. And I know it's confusing that we're both named Chris, but sometimes it just works out that way.
Yeah, fortunately we have active accents, so it should be okay.
Yeah. Okay, so if you could bring up the slides for the Sentinel hardware, please.
Okay.
Let's go to that. There we go. So a couple of things that we wanted to do at VTI Instruments, and that was to basically expand on the capabilities that we had with our VXI products. We've just recently released our Sentinel EX product family, and one of the things that we continue to do is we want to be able to offer our customers the ability to be able to work with good turnkey applications like tests for I-DEAS, but we also have driver support for Windows and Linux for those who do like to write their own code. There's not many out there. Most customers, I think, prefer a turnkey solution, but there are customers who need applications or need to do things that you can't get on a turnkey package. With the Sentinel EX hardware, we do have some new things. Similar to our VXI products, we used to have a DSP that we could use for custom onboard processing. We've put in a large FPGA in each one of our cards, and we have some future capability that will allow users to be able to take advantage of that. We've improved the capability from a signal conditioning standpoint. Not only do we have the ability to do IE, PE, and voltage measurements, but also charge. The other technology that we wanted to leverage was IEEE 1588, and we'll talk a little bit more about that, but that gives us the ability to truly distribute the measurements and still keep everything synchronized, as well as the ability to timestamp the data. We wanted to improve the performance. Everything is 24 bits, but we do have customers that need higher sample rates, whether they're working with scaled models or they're looking to do things like pyroshock measurements. One of the values that we saw with the VXI hardware is that customers were able to leverage the same platform for a lot of different measurements, and sometimes that requires that higher sample rate. Now, we also needed higher throughput, especially as we go to higher sample rates, and I'll show you some information on that. But here we have with our Sentinel EX platform, one hardware platform that's designed and capable for doing everything from shock and modal testing all the way to rotating machinery and high-speed data acquisition. So we wanted that in one family. Next slide, Chris, please. So one of the things that we just recently announced was our end of life for the VXI products, the 1432. Now, these are not all of our VXI products, but just the E1432 or the VT1432 product family. So just a little bit on that. The end of the life announcement was made. You can still purchase any of those products new from us through April of next year. Following that, we'll still maintain at least a 5-year or better support life where the instruments will still be able to be sent in to be repaired, calibrated, serviced in any way. And what I'm showing here is just kind of a migration path, if you will, from some of the VXI products. You'll see that we have on every one of our Sentinel EX, or sometimes we call it EMX series hardware, we have superior performance than we had with any of our VXI modules. And this stuff is available on our website. Next slide, Chris. So one of the things that customers told us was they needed a system that was smaller, more portable, able to be, they still wanted the reliability and, the things that they came to trust from the VXI products. And we have customers that have been using the same products for over 20 years, and they still deliver high quality data. They still want that same capability, but they wanted it in a smaller package. Here you kind of get kind of a comparison. Here I've got a standard VXI 13 slot chassis, and if I put in one source card, the VT1434, and then I load up 11 of the input cards, you'll see that I've got a solution that weighs, for 176 total channels, it weighs almost 100 pounds. An equivalent 18-slot chassis in our EMX series, we get more channels at almost a third the weight and a much smaller size. So we get a lot more density and it makes it a lot easier to manage, not only for more channels in the same space, but also easier to manage and move the hardware around. So that was one of the things that we wanted to achieve with the EMX hardware. Next slide, please. The other thing that was key is we have a lot of users who want to be able to distribute the measurements. With the LXI standard that we leverage with this hardware, we have the ability to use IEEE 1588. Now, the IEEE 1588 standard allows us the ability to synchronize multiple measurements, not only noise and vibration measurements, but we can also synchronize data from other data sources. But here's a nice graphic where users can take multiple chassis and just using a standard Ethernet hub, they can bring that back into a central computer, and they've got the ability to distribute each one of those chassis. Now, there are some depends and ifs, if you will, but with the right switches, you can get synchronization into the hundreds of nanoseconds, which is more than sufficient for any of the noise and vibration measurements that most of our customers need. And what that really translates into is how much phase error is allowed. But typically it's less than half a degree phase error across multiple chassis, and these can be scattered anywhere around the structure. So this 1588 gives us the capability to do that. And what's nice about it is using the VTI chassis and our gigabit Ethernet controller, the synchronization happens automatically. You don't have to have any special cards. You don't have to do anything. All of that's taken care of. So when you use Test for I-DEAS, if you have multiple chassis, it automatically synchronizes those for you. Next slide, please, Chris. The other, I would say one of the things about the VXI hardware that in the beginning served it very well was it had the ability to scale up. But over time, it didn't have the ability to take or throughput data with large channel counts. You'll see at the top there a standard VT1432 module. Typically we have, with no matter which slot 0 you use, whether it was an Ethernet slot 0 or a FireWire or a USB, we typically were seeing about 5 megabytes a second. Using the 1432B's maximum sample rate and 24-bit data, you'll see that the maximum number of channels that we could continuously throughput was 11. We also had the ability with the VXI hardware to use a throughput disk. So using our VT2216 throughput disk, we were able to increase the data throughput up to about 16 megabytes a second. But you'll see we've only increased the ability to up our channel throughput up to about 40 channels. With the EMX hardware, we get almost a complete order of magnitude improvement in that. So now, with 4250 and using the gigabit Ethernet, we get about 90 megabytes per second per chassis, which means that we can easily get up over 200 channels, and even with the other options that are available with PXIe, like cable PCI Express, we can get to systems that not only get to much higher channel count, but are able to throughput data at much higher data rates. And again, I kind of want to emphasize the power of the Ethernet. Each chassis has its own, if you will, data pipe back to the computer. So using a high-powered switch, I can take multiple chassis, each bringing data in at 90 megabytes per second, and get to very high channel counts at very high throughput numbers. And all this is possible with the new hardware. Next slide, please, Chris. So just a quick summary of the hardware, what we're talking about here. The Sentinel EMX products, depending on how you look at it, it's the 4th or the 5th generation, originally started by Hewlett-Packard, then carried on by Agilent, and then about 11 or 12 years ago, that whole product family was purchased by VTI Instruments. We wanted to be able to bring a lot of new features to what we had with the legacy VXI products in this current generation product, including the portability that we talked about. You'll also see an improved or a lower cost, better performance, higher throughput, and then that ability to distribute those measurements. Next slide. So right now we have 3 different chassis. We have our CMX09, which is our 9-slot chassis. It's kind of designed for semi-rugged operation and portable applications. But you've got 9 total slots to be able to put cards in. It does have a nice health monitoring capability. It's difficult to see, but the power switch there has a number of displays. The user can cycle through to get what's my fan RPMs and what's my temperature on my slots and how much voltage I have on the back plane. And it gives you kind of a nice way to understand or get some health monitoring on the chassis. It does have a very high-speed Generation 2 PCI Express backplane, which gives us a total capability of 8 gigabytes on the backplane. And we do have the ability to rack mount, handle mount, as you see here, or even shock mount that chassis. In addition, we have an 18-slot chassis called the CMX18, which has many of the same basic features, only it's in a traditional 18-slot designed primarily for rack mount use. But with these chassis, it gives us a lot of flexibility. And then on our next chassis, next slide please, Chris, we have what we call our PMX04, which is more portable. It's a little 4-slot. This is a future product that we're still working on getting a few of the bugs out, but it should be available shortly. Designed to be completely portable. It has an Intel Core i7 quad processor, a 14-inch touch screen display, but you can put up to 4 of the EMX cards into this chassis and use it for portable testing applications. Next slide, please. So real quickly, just want to kind of go over each of the individual cards. We have what we call the EMX 4250. It's going to be kind of the workhorse. It's a 16-channel card, similar to the VT 1432. But here we've got 24-bit performance with a 204 kilosample per second per channel. You do have your AC or DC inputs with IEP. Now, one thing we added was we have a lot of customers who use our products with critical tests for a lot of different applications, and we put in more capability in the signal conditioning. For example, one thing we do have is the ability to change the IEPE current from either 4 milliamps to 10 milliamps. Ideally, you'd go to the higher current for long cable runs, or even if you're doing pyroshock testing. It gives you the ability to maximize the usable range of the accelerometer. Now we have a number of different breakout boxes. Here we're showing an 8 and a 16 channel. The breakout boxes do have an LED that shows open and short circuit. It actually can be programmed to also show overloads. You've got the ability to do single-ended or pseudo-differential, and you've got a number of different input ranges on this card. So it's a very capable card that gives us additional functionality and capability than we had with the VT 1432. Next slide, please, Chris. In addition, we also created the ability to have more flexibility with the breakout boxes. So here we're showing an example of a configuration where we have a carrier for a small breakout box that bolts directly onto the chassis, so that for somebody who wants to do a 64 or even 128 channel portable test, they can pick up this chassis and carry it around and be able to have the digitizers and the breakout boxes all bolted together without having to use a 19-inch rack. So it gives that ability to do, portability with some of the testing options. Now the breakout box can also be individually set up as an 8-channel box, and it's designed to be able to place, anywhere around the structure. And we're also looking at future breakout boxes to add additional capability, things like MEMS sensors and others. So we're actually looking at that right now. We just also released a 32-channel breakout box for higher densities. Next slide, please. The EMX 4350 is our high-performance card. Here we've got a 4-channel card. You've got a 24-bit ADC with sample rates up to 625K per channel. You've got your AC and DC coupling. Here we've got more flexibility to even do ICP or IEP current from all the way down from 2 milliamps up to 20 milliamps. So again, more capability there on the signal conditioning to be able to give the users more flexibility. Here you've got a BNC connector right on the front. You still have your open and short circuit LED to give you that indication. This one does have single-ended and true differential capabilities, a lot of different ranges. But again, this card is designed for very high performance noise and vibration applications and high-speed digitizer type capabilities, all on one card. The next slide, please, Chris. So this card is very similar to the previous one. It's called the EMX 4380, 4-channel card, 24-bit, 625K sample per second. But this one adds the ability to work with charge-type transducers. So again, it's got the signal conditioning to work with AC and DC inputs, ICP or voltage, or even charge amp, all in one card. And here, this gives our users the ability to have one hardware configuration, and through software can configure that card to take voltage inputs, IEP, E transducers, or charge inputs. Everything's B and C input. You do have the open and short circuit LED again on this card. And all of these cards do support TEDs, by the way. The next slide. This is the last product in the family. This is the EMX 1434. This is our source and tachometer card. So we've got 4 sources with 2 tachometers. Now, here you've got a 24-bit source with sample rates, output rates up to 204K samples per second. You've got multiple modes, just like you had on the VXI product. We do have a much higher performance tachometer than we had on the VXI. You've got 64-bit tach with capability up to 1 megahertz. The tach can also support 25 or 250 volt ranges so that you can work with a wide range of different tachs. And so you'll see that there is actually signal conditioning on those tach inputs. And we also added some DIO. And the digital input and output capabilities there for flexibility. Some users may need to be able to shut down another process or something like that. They can use that digital input for that. And we do have a COLA as well as the same safety shutdown feature. So the card is designed to be able to use in critical applications where customers have outputs from this driving into shakers for things like spacecraft or high-value items where they can't risk damaging the article. So oftentimes they've set up a mushroom button to be able to shut it down, or any type of external process can be used to be able to take that shutdown connector to ground, and it will immediately ramp down the source output so that you don't have anything coming out that might potentially damage your structure. So the cards have been designed with all the safety features in there to be able to use for any of those high critical, high value or critical applications. So this is our Sentinel EMX product family. We're very pleased to be able to work with the guys at Maya. And I guess, Chris, at this point, I think that's all I had as far as slides. And I think we're about a few minutes over as it is.
Yes, we're a few minutes over. Right. That's certainly the end of the presentations. I saw a question on the line, and maybe I can quickly go through those. Of course, we're past 3 o'clock, so if people want to sign off, then that's perfectly understandable. And looking at the questions we have, UFF appears to be the only acceptable model format for geometry. Do you know if Patran or Nastran are able to produce a UFF file, or do you provide a converter? We do have an option in that format. For Patran, I'm not sure if it supports the universal file format, but I would think commonly it could write out a Nastran file. Is there a way to import a list of transducers? Yes. Again, there's two options. One is the universal file format, and the other one is to use our channel table spreadsheet format. If you use that, you can simply load up the transducers, and on the channel table view, you can select transducers from pull-down list. Third question, I've used I-DEAS to collect hammer data and received a comment about a double hit. And the comment that it still the software still showed a double hit even after that had been corrected. Is that a known bug? Do you know the answer to that, Rick?
It may be. I'm not sure off the top of my head.
Okay.
I'd have to look it up.
And there's a general question there about coherence, and I think that's probably something we better to deal with offline as we're getting into test techniques and things like that, which we're more than happy to help with. But it sounds more like a support question than something for this format. And a question about how many Macs. Well, we can compare. Yeah, with our Macs, always use two sets of results and compare those. Are there any other questions from those that are remaining? Trying to unmute people that I unfortunately had to mute during the presentation.
The script language.
Totalny dzień zaczyna być w tej chwili w ogóle. Jest 30-40% strat pakietów.
Sorry, I'm done.
Nie powinien być w stanie wyłączyć mikrofony, bo tak na tym polega seminar, nie rzeczy, z czego dają w kawiarni.
Well, Chris, if there's anybody who has any follow-on questions, how's the best way? We have a support node and a phone number, and of course they can call Rick as well. Is there any way for us to go ahead and to follow up with any, so if they have questions, they can send that in?
Yes, certainly. I think well, the easiest thing is, I think if it's existing customers, then of course you can always answer questions through our usual support line, which is support@mayahtt.com, MAYAHTT.com. I think it's for people with questions prior to purchase, then it's probably best to contact VTI.
Now, for VTI, it's fairly simple as well. We have a support node, which is support@VTIinstruments.com, or sales questions with sales@VTIinstruments.com. And will these slides be available, Chris?
Yeah, we can make them available in PDF format, certainly.
Well, Chris, on the behalf of VTI, I'd like to thank everybody who was able to call in, and for your time as well, Chris. And if anybody has any questions, please feel free to contact us, and we'll see if we can't follow up with the information that was presented here today.
Okay. Well, thanks, Chris, for your support. And also, I'd like to say thank you for everyone to connecting. And as Chris says, any questions, we'll be more than happy to answer them and help you out with any issues. Okay, thanks, everybody.
Too late.